Good morning, class. Today we're going to be going over Lesson 3's guided practice and independent practice for Unit 9. This subject is about another quadrilateral that we're going to be investigating, which is rectangles. So I'm going to begin. I'm going to do the guided practice number 1, 3, 6, and 8. And then I'm going to do independent practice number 14, 15, and 16, 20, and 23. There is some more independent practice for you to do, but these examples will help guide you through that process. And if you have any questions, feel free to reach out to me anytime. Definitely, let's begin. So, the book for problem 1 and 3, there's a Jamaican flag. Even though I don't have it precisely how the book is drawn, it's essentially a rectangle with line segments going to each vertice opposite of each other. So this is like a diagonal connecting the vertices. So we're given information. Point E is at the center right here of where the diagonals intersect. And from A to E, it's 5.8 feet. From A to D, it's 3 feet. And angle EDC is 33 degrees. So it wants you to find side BC, which is right here. Whenever we're looking at rectangles, the opposite sides, according to a property of rectangles, this is on page, let me just take a quick look. This is on page 823. So if you look at page 823 in your textbook, there is a diagram of a rectangle. It says A, B, C, and D. And it basically is kind of like a parallelogram where the opposite sides are congruent. And basically we have a 90-degree angle at every corner, basically, where a vertex is, like A, B, C, and D, they form a 90-degree angle. And so that's basically the property of a rectangle. So if we look at AD, AD is 3 feet. BC is the opposite side, so that means that BC is going to also be 3 feet. Now we're looking at the measure of ADE. So if we look, the measure of ADE, we always do the second letter. So D would be the second letter of this angle. So it's ADE. That's where we're going to draw a symbol for angle. And we're going to try to figure that out. Well, according to this property up here in this diagram, we know that 33 degrees and the measurement of ADE is equal to 90. So we know that it's going to equal 90 degrees AD and E plus 33. So we're going to just take 90 degrees and subtract 33 because these two angles, ADE and EDC, I'm going to write that down, the measurement of ADE plus the measurement of angle EDC equals 90 degrees. And since we know that angle EDC is 33 degrees, what we can do is subtract 90. We subtract 33 from 90 and we'll get ADE. So 90 minus 33, 10 minus 3 is 7. We turn that into an 8. It's 57 degrees. So we know that the measurement of ADE is 57 degrees. Okay, so now we're going to move on to problem 6. And problem 6 is, let me just write this down. We again have to use algebra to solve an equation to find an unknown, I believe, side length or segment of a rectangle. So let me just draw this up on the whiteboard and we will begin. So problem 6 has a diagram just like I had with the Jamaican flag, we have a rectangle with two diagonals, and this is L, M, N, and P, and there's also a 90-degree angle symbol, and it says for number 6, the problem says if MN equals 5x plus 2 and LP equals 4x minus 3, find MN. All right, so what we're going to do is label the diagram. Well, we know that MN is 5x plus 2 and LP is 4x minus 3. And so since they are opposite sides of the rectangle, we know that they're congruent. So in order to find MN, what we're going to do is we are going to set them equal to each other. So we're going to have 5x plus 2 equals 4x minus 3. And now we're just going to solve for x. So we're going to first subtract 4x to both sides of the equation. That gives us x plus 2 equals negative 3. And then we're going to have x plus 2 equals negative 3. We're going to subtract 2 to each side, and we get x equals negative 5. I know many of you will stop at that point, but that is not the proper solution. Basically, we're going to have to plug that number in for the equation. And if memory serves me correct, there was a error in the textbook because our solution is going to be negative. So I'm just going to show you the process because the other problems I know in the textbook, I think there was a couple errors in this section, but I'm showing you the process so that you understand how to do it. So what we would have done is said, well, MN is going to equal 5x plus 2, and we're going to plug in negative 5 in for x and add 2, and that's going to give us negative 25 plus 2, and that's going to give us negative 23. So even though that is the correct solution, a side length of a rectangle, can it ever be negative? And so the answer is no. This is one of the errors in the textbook. I remember specifically this section has that. So if you come up with a strange negative answer for a angle or a side length and you did everything correctly, it's just an error in your textbook. I'm sorry about that, but that is just something that happened in this section of your textbook. So again, that's the process. We're going to set LP equal to MN, solve for x, and then when we get x, we're going to plug in our x value into MN to get the length. All right, so number 8 is a specific type of problem that is very important for this section. We are going to be using what's known as the distance formula. So the distance formula will help us determine whether a figure is a rectangle. So we have this graph that looks like this. We have point C, and that's at 2, 9. We have point T, or F, which is at 3, 6. We have D, which is at 5 and 10. And we have E at 6, 7. Okay, and it says, graph each quadrilateral with the given vertices, determine whether the figure is a rectangle, justify our answer using the indicated formula. So essentially, there is a property that I can use up here. I'm just going to erase this section. And basically, if we know that the diagonals length are congruent, so that means that this diagonal length is congruent to this diagonal length. So ln is congruent to the distance of MP. So if these diagonal lengths are the same, we know that it's a rectangle. So essentially, what we're going to do is use the distance formula to find the length of each diagonal. So we're going to say EC, we're going to find that length. So the distance formula, again, remember it is x2 minus x1 squared plus y2 minus y1 squared. And that will give us the distance. And so what we're going to do is we are going to first find EC, and that's going to be, we're going to take 6 right here, 6 minus the other x value of C, which is 2, and we're going to square that, and then we're going to take 7 and subtract 9 and square that. So when we do the math, we're going to get the square root of 4 squared plus negative 2 squared. So that's going to give us the square root of 16 plus 4. So that would give us the square root of 20. So I am going to leave it as a square root of 20 because that is a precise answer. So if side DF, or diagonal DF, is equal to the square root of 20, because the diagonals are the same using the distance formula, then we know if this quadrilateral is a rectangle. If they're not the same, then it's not going to be a rectangle. So we're going to use this distance formula again, and we're going to plug in, since we're using D and F, I would take the bigger x value and subtract the smaller, so we're going to go 5 minus 3 squared plus 10 minus 6 squared. Doing the math, we're going to get 2 squared plus 4 squared equals the square root of 4 plus 16, which is in fact the square root of 20. So since the diagonals are equal, we know that DF is congruent to EC. We can say, because they're both the square root of 20, that yes, this quadrilateral is a rectangle. All right, so that concludes the guided practice portion of the lesson, and now we are going to start the independent practice. So let me just log in to the Chromebook that I'm also using to get to lesson 3. All right. So number 14.